Hello guys, my name is Michael. Welcome to my YouTube channel. Today I'll be discussing with you the Inter-AS MPLS Layer 3 VPN option B. Please note that this is actually a continuation from the previous video that I uploaded some days back, and I hope you enjoy this as well. Thank you. The agenda for today's video is based on the list that is on the screen. This includes the components of an Inter-AS MPLS network, a recap from the previous video just to bring you up to speed in case you did not see the previous video. Also, the case study for this particular video, which is the option B that I'll be discussing today. After which, I will also share with you a configuration section, which is a reflection of the work that needs to be done, how the routers need to be configured in order to be able to deploy this solution as expected. Then we can do a very quick summary as a conclusion on this particular topic. So, about the components, these are the routers in the Inter-AS MPLS network that you may come across. You have the provider router, which is always seen to be the core router, the internal router of a service provider's backbone network. Usually you call them the internal core router. These routers do not have a direct communication with the customer's network. Then the provider edge router is that router that sits at the edge, the access point, the access position of a service provider's network. This router has capability to communicate with the P router using the MPLS label and also with the customer edge router using IP routing. There is also another router which is actually the one that defines your network to be an Inter-AS MPLS network. And this router is the Autonomous System Boundary Router, otherwise called the ASBR. And this router is also a similar PE because it communicates with your internal MPLS network routers and also an external router which belongs to another service provider. This is different slightly from the PE because depending on the option that you are deploying, it can act similar and exactly like a PE to another service provider. In that sense, you will be talking about option A because there is no label exchange between the ASBRs. However, if you are using this particular router in an option B, for instance, or say option C, you will be talking about exchange of labels, which now differ from the typical PE router. And this is also what you find particularly in an Inter-AS network environment. There is also the customer edge router, which is IP capable because it does not exchange labels with a service provider network. It pairs directly with the PE of a service provider. And these are the routers that you will find in most of the MPLS networks that you find around the world today. Particularly when you come across the ASBR, then you will be talking about an Inter-AS MPLS environment. I need to let you know also that every information that you find which reflects the design, the topology, IP addresses, configurations in this illustration are not reflections of any real-life entity or infrastructure. These are typically born out of my own imaginations, which are the motivation and the inspiration behind all the designs that you find and the configuration part also in this video. So please take note. Now to the recap. Recap on the Intra-AS MPLS. Typically, this is what you find when you're dealing with a single service provider. This means all the routers that are operating in the MPLS service delivery are under a single administration. In other words, they all operate within an autonomous system. In an intra-AS MPLS VPN, there is only one service provider that is operating in the space of service provision. Hence, there is no inter-AS communication. That is, everything is done within a service provider's network. That takes us to why we need inter-AS MPLS. Option A, which was discussed in the previous video, like I said before, please check out the link to see the previous video if you want to see the full details. There are several reasons why you could consider inter-AS communication, and this can be around the desire or requirement of customers' business. And remember, your design is always subject to the business goal or business requirement and other design factors that may come into play, which is also going to be subject to the business requirement of the customer. To consider in terms of your deployment, because if you are dealing with a scenario where you have up to hundreds, probably thousands of customers or thousands of services to deploy, and you're considering this, then you are going to be putting a lot of overhead on not just the administrators, but also on the infrastructure, because here it means if you have 1,000 customers which should have this particular solution deployed to them, then it means that you would have 1,000 lines between these two routers. And that means a lot of memories, because they have to keep a copy of routing for each of those customers. And imagine if one customer has up to 10,000 of prefixes, then it means you will be putting a lot of memory resources, CPU also in consideration. And so that is why we have to consider how to overcome this limitation of the option A. Talking about option B, we were able to highlight some limitations of the option A, which gave birth to the consideration of option B. In this scenario, we have been able to overcome that limitation of having to create multiple inter-AS links between the service providers that are playing part in the delivery of this solution. And that is replaced by a single inter-AS link between the two service providers. In this case, you still have everything that you had before, which includes the PEs and the ASBRs and of course the Cs. And with that, you are able to simplify further the configuration between the two service providers, particularly on the ASBRs. Every other thing remains the same on the PE and the converging part between the PE and the ASBRs. But there is something that you find when deploying the option B, and that comes with overcoming scalability limitation, also reducing the overhead on the ASBR, and there is no more requirement for you to have a dedicated inter-AS link to each customer. With this, you are able to provide scalable solution that spans across multiple service providers and also still deliver your service to the customer. Remember, inter-AS MPLS VPN is basically a connectivity solution. So the difference between the option B and option A is in the configuration that you have on the ASBR particularly, because in this scenario you will be configuring something more special, which is the automatic route filtering feature that needs to be disabled on the ASBRs. Don't be confused by this design. It is only showing you a redundant path between the service providers. You don't want to put a single inter-AS link between service providers in order to deploy this. It is always better for you to consider a backup path so that you can eliminate a single point of failure in the scenario where you have this particular link to be disconnected for any reason, if you do not have a backup path, then you will end up isolating this customer from reaching out to other branches that may not be provided or connected by this particular service provider. Imagine a situation where you have this particular link as the only inter-AS link. It means the only customer sites that will be able to reach these servers at the campus site are the ones that are connected by this particular service provider. And by design, it is always good for you to consider that option. Except if the customer's business requirement only need one, then you can go with that. However, this is not a good design from a perspective of high availability and business continuity or disaster recovery in such cases. So please take note, it's always good to consider backup in order to prevent any single point of failure, which can be more expensive from a business perspective. Now back to what I was saying, the automatic route filtering feature is that feature that allows the ASBR to automatically filter away any prefix that is coming from any VRF from entering into a particular VRF. For instance, if you have a prefix that is coming from NAM or VRF-A, let's put VRF-A and AP VRF-B, for instance. When these prefixes get to the ASBR4, for instance, it means that they will not be interlinked into themselves on this ASBR. And when this ASBR is advertising those prefixes, it only does this in a separate MP-BGP table. And the MP in this case is a multi-protocol that allows these routers to communicate on other protocols that will be carried over the BGP protocol. So therefore, you need to disable this particular feature to allow the ASBR to put a copy of the prefixes that are coming from other VRF into one, I would say in this case, a global multi-protocol BGP table that is advertised to all its peers. Now, the design of this scenario is such that I have a route reflector which is pairing with all other routers in this service provider network, and the same thing also in this case. I will show you more of this in the configuration part. As I was saying, the MP-BGP is that protocol that allows your ASBR to communicate with the PEs and the route reflector in this case. Also, the option B comes into play when you disable this ARF feature and pair with the remote service provider ASBR. They are not going to be exchanging levels by enabling MPLS LDP on these interfaces. What you just need to do is to pair with each other using the MP-BGP because they are running in different ASs and they need to run over the multi-protocol BGP instance. There are different options that you may consider when deploying the option B: the next up self approach, the redistribute connected approach, and the eBGP multi-op approach. In this video, I will do more of the next up self. Then I will also do other videos that will capture how to use the redistribute connected and of course the eBGP multi-op method of option B. Each of the options that you need to consider is dependent on what is the limitation or your design consideration that you have in your network as a whole. Focusing on the next up self, when you are configuring the ASBR in the option B approach, you need to specify that the ASBR has to rewrite the next up address on every prefix that it lands from the remote service provider. This makes sure that the ASBR will replace whatever is coming as the source of that prefix with its own IP that needs to pair with the internal router. in this scenario, you will find out that the ASBRs in the service provider network have to pair with the route reflector and specify that whatever is sent to you, use me as the next up. That is the essence of this. And that really makes sense because BGP principle says the next up must be reachable for any prefix to be considered reachable. So that is the essence of using this next up self. If you are in a situation where you have limitation communicating with this service provider, and security wise, service providers usually will not give you their internal route. They can only send to you a transit route that needs to pass through them in order for you to get to them in terms of connectivity. This is what I was explaining here. With this approach, the ASBR configured to rewrite the next hop address to prefix received from remote ASBR via the MP-BGP with the local addresses when advertising them to the MP-BGP. So don't be confused with these terminologies. These are just showing you that the MP-BGP is the eBGP that is formed over the multi-protocol BGP protocol or process between these ASBRs. However, the MP-BGP is showing you that between this router and all these internal routers, particularly in this case the route reflector, it is pairing with this route reflector over a multi-protocol BGP, but it is internal because they are in the same AS. In other words, it means you do not need to bother about reachability to this ASBR from this PE, for instance, because here you have instructed this ASBR to rewrite this next hop address with its own address. So the benefits and of course the drawbacks or considerations, as you may call it, when considering option B. There are lots of factors that can push you towards considering any of the options that are available. But it is always good for you to know what is unique to each of these solutions so as to make the best of your design decisions driven by the business requirement of your customer. One of the benefits of this is that simplification of implementing this solution, because now you don't need to configure multiple inter-AS links and pairing each of them. That's quite huge to consider, especially when you are considering multiple numbers of VRFs. Remember that you do not need to exchange label using LDP on this link. Okay, you do not need to do that. All you need to worry about is the MP-BGP. So you are configuring MP-BGP between these ASBRs. Okay, the other one is that you are able to reduce the overhead on this particular router from the perspective of having to keep a separate VRF tables per customer, and it means that you can save yourself a lot of memory consumption on this route. So with this option, you are able to collapse all those prefixes into one global routing table that is for the multi-protocol BGP, and that will be easier to manage. This also reduces the operational complexity. As you can see, you don't need to worry so much looking for one VRF or the other, especially at the ASBR level. And you can also keep the single inter-AS link. Then the drawbacks on this is that you need to be conscious of security situation, particularly from the perspective of having this ASBR keeping multiple prefix entries. It means at this level, you can end up switching traffic that is meant for one customer to another customer just at this point. And that is why you need to be conscious about that. If you have to filter specific prefixes based on prefix length, based on source, and you need to consider that as a very serious option before you go ahead to disable the ARF. In this case, you cannot deploy QoS based on IP as you would have been able to do in the case of option A. That is simply because in this case you are not able to separate a customer's traffic based on VRF. Remember, all of them are in a global table. So your QoS deployment is only going to be based on MPLS experimental bit. In a couple of minutes, we'll go into the configuration section, and I would like to share these assumptions with you. First is that IGP sessions are converged in each of those provider network. MPLS is also converged. There are no configurations that are special, and all VRF on each PE have been configured, except for R11 in this case, which was deliberate, just for you to see how that is done, in case you're not familiar with this solution. Here is the background information that captures the service provider VRF information and also the enterprise network. As you go to the configuration section, these are things that are required in order for you to achieve the option B by next stop self. On the ASBR, you need to disable the ARF. You will see this more in the configuration section. And of course, you can pair between the ASBR. Remember, there is no need for LDP or IGP or VRF configuration over the entire link. So when you're configuring the ASBR with the internal router, you need to specify next stop self. This is to rewrite next stop address on remote prefixes as this advertises it to them. Okay. In case you are using the route reflector method as seen here, then it means this ASBR does not need to pair directly with the PEs. For any reason, it will only just consider the route reflector. On the PE, you have options of how to get the prefixes that are coming from the remote side. Say, in this case, the route target of this particular network as configured on this PE is something in this range. That is this one. But it is different here because in this service provider network, this is the VRF information. So you need on the PE to import the route target of the remote prefixes in order for this PE to get the routing information that is coming from the remote side. If you do not do this, this router will not be able to inject those prefixes in the local table that is for this VRF, which should have been able to reach the campus network. So take note of this information as you go on with the configuration. And remember, on the route reflector, there is also need for you to disable the ARF. Reason is because by default, it will filter them away. It will not inject them into the local VRF. So it is important for you to consider these two options in case you are configuring this. There is also another approach that you can take to overcome having to configure the PE and the route reflector, and that is using a rewrite option based on extended community from the ASBR. That means as the ASBR receives those prefixes from the remote service provider, then it will rewrite whatever it has for the RT, the route target, to become the local route target that is known to this PE particularly. In that case, as this is done, the PE receives those prefixes directly without you having to do this. I will do a video that captures that one, but I hope this will be helpful. This section leads us to the video where I show the configuration steps that you can take in order to get this implemented. You can lab it, ask questions if you have to. I have also shared some references in the description section in order for you to take your time at your own pace to get this well understood. Thank you for watching this video. I hope you found this section helpful. In order for you to continue with the configuration of this particular video, kindly click on its URL in the description section below, and I hope you find it interesting. Thank you, and remember, learning takes you through the best part of earning.